Yes. Um, it's mechanics. We are just straight here for mechanics. Applied mathematics. Applied mathematics. I believe you can be able to see this question that is here is 2.26 and when I'm my textbook is in the laptop, so I won't be able to see much. I won't be able to see much. Yes, the question 2.26. This is the first question that we are going to solve. That's the first question that we are going to solve. Is the first question we are going to solve. And if you can check here, we were given a diagram. We were given a diagram, and diagram we're having. I believe you have it in your textbook. Therefore, this is the A side. Then I put a small a. On the B side, I put a small b. I believe even yourself you can be able to see what's happening. Then here we have to find height. We have to find the height of right triangle. The height of right triangle, and the height of right triangle is gonna be AB. These small a's that I symbolize here time over the what do you call when you're using what is it? Pythagoras. Yeah, Pythagoras theorem. Yes, you're going to get square root a squared plus b squared. Then this is going to be your height. It's going to be your height. Your height. This is going to be your height. Then if you check very well, then we were given the distance of A and B, which is 500 and 400, which is in millimeter, but you can still use it by the way. Then we calculated and we found our height. We find our height. This is the height of right triangle. Then we have to find the height of the triangle. We have to find the height of triangle. I wish I could write, but I'm using a laptop, so I can just move things here. We have to find the height of triangle. Remember, we are going to have triangle when we are going to calculate the p, because I suppose maybe to draw how the diagram must look like. But I believe by just you looking, you can figure something out. Then we are taking the height of right triangle and multiply it with p. Remember, our p is a force. There is the formula. MO equals to height of right angle triangle times p, which is our force. That's why here I said 0.31234 times p equals to 200. This 200 is that one that we were given. We were given in our problem. Yes, therefore there it is. We found p. That p, it is the force that you have to what can I say? What is that word again? Uh, you have to take it to components. You have to resolve it into components. The p that you got there is not the final answer. No, it's just the p for you to be able to get your y and your x. For you to get your y and your x, which means is that resulted part. Yes. Therefore, after getting that one, you have to resolve it into x and into y. And our y, our y is 400, which is gonna be y e, then 5 plus 500j. Then after that, you're supposed to find the what do you call, the magnitude of p, which is square root. Remember, which is square root. Therefore, there it is, everything. I wish I would have written everything, but the time. Then there it is. There we found the answer for that magnitude. Therefore, now we are going to calculate the unit vector. The unit vector along AB. Remember, that's where P is, because it have to hit in between there. It have to hit in between. It is acting there in between. So that's where it is hitting between A and B. So we take that P that we calculated before. We take that P, as I told you, it is a force that it is meant to be resolved into x or y. Then we take our magnitude there, then we multiply the two to get our main P, that they asked us to calculate, which is gonna be P equals to 400I plus 500J. That's how we solve that equation. If you are not understanding, you can write so that I may explain, because we're gonna go to we are going to go to next question. We are going to the next question. So if you are understanding, it's fine. We are going to the next question right now, which means I believe that we are done with 2.26. Now we are going to 2.28. I will improve my things this side. Let me check which one is 2.28. 2.2. Oh no, this one is 2.4. I can't remember. Okay, yes, there it is. 2.28. 2.28. 2.28. There it is. I wish, let me just go to the question so that I can, where's the textbook, so that I can be explaining, seeing the question. The textbook. I'm not finding the textbook, guys. Jesus Christ. I don't know where is the textbook in my phone. Yes. What is happening there? We are first finding T, the magnitude of T, as a notation of T, where we are going to find T cos 45. The 45 party, if you can check there underneath, I showed where how did I get 45 degree. I said theta, tan theta equals to opposite over adjacent, because if you can check that diagram, we were having 30 at 36 as a height, and we were having 16 plus 20 on the x-axis. So I got the theta of the whole triangle, of the whole right triangle. That is the theta of the whole right triangle. That is the theta of the whole right triangle. That is the theta of the whole right triangle. Of the whole right triangle. So that's how I got the 45 degree. I calculated it from there. I used the 36 over 20 plus 16 to get the theta of the whole right triangle. Is question 2.28. Then yes, then cos 45 is square root is 1 over square root 2. Then that's how it is. Then we have to find the r for t. Check where t is. You are going to find that there is 20 there, but that 20, it is pointing downwards. So the r for t is pointing downwards, so it's gonna be negative 20 I meter in notation. Then we have to find our MB, which we are going to say R times T. Remember, we have already calculated our T, or we have already having equation for T, and we have R already, which is our negative 20. So so here what I did, I took this. If you can take your calculator and say negative 20 times 1 over square root 2 is going to give you 14.14. 14.14 t. Then after that, you substitute your t. The whole of t is gonna give you 400 after you substituted everything for MB. Then what you're going to do, I wish I could be pointing at the textbook. So what you're going to do here, now we have W, which is the weight. It is pointing down, so that's why it is negative 25 J. K kilonewton. That's why it has a negative. It's negative 25 there. So what we are going to do, we are going to take the R. The R for W, if you can check, it's 16, but check the direction, it's negative. So we are going to say MB equals to R for W times W, referring to weight. So here I calculated everything. So what you're going to do is just to take negative 16 times 25, then you're going to get your 400. You're going to get your 400. Then your C, the question C is just the total. Is just the total of what you got from question A, question B. You plus it, it's gonna give you negative. It's gonna give you 0. It's gonna give you 0. I will try to improve my ways of doing things so that I can explain it in the way that you will understand. I believe everybody they can see. Before we move into a next question, 2.4. Let's move to 2.4. Yes, there is just too close. It's too close. 2.4. Let me move this one away. Yes. I thank God there is network. Yes, there it is. 2.4. 2.4. Did I grab 2.4? Yes. 2.4, if you can check very well, we have our coordinates. The coordinates of B, which are 4, 2, then 2 and 0. Then the coordinates of A, we have 0, 0 and 2. Then we have to find R for BA for the combination of AB or BA, then what you do, you take the first one and the second one, the third one, and you minus with you are minusing them. You are saying 0 minus this one, 0 minus this one, 0 minus this one, which means is your is 3D, is 3D on its own, is 3D on its own, is 3D on its own. So there we go. There we go. What is appearing there on the screen? Is not exactly, it's not what I want. Yes, then after that, when you have then after you have done this, you are going to get your RBA, and there it is. After that, you get the magnitude, and that's how you get it. You're just going to use the square root for this one and substitute. You get the final answer. Boom! This is how it is. Then we were given 80. 80, it was the force that was already there. So we take this force and multiply it with the magnitude that we got. Then we put it there. Then we get our P. We get our P. We get our P. Then the question is still continuing. It's still continuing. Still continuing. Now I'm tired of talking. Yes, just look at it, these guys. Just look at it. Yes, just look at it. That's how we work it out. Here there was no space, so don't be surprised. It's negative 66.4 I, negative 32J plus 32 K. Yes, then that's our final answer. This final answer, this is our final answer. That's our final answer. Let us go and do the last one. And now I'm tired of talking. I'm tired of talking. Let's remove this one. We go and do the last one. Let's do the last one. Here is the last one, 2.7. 2.7 is the last one. So the question was that calculate the CR. Now I'm tired of talking serious. Just look, there is the formula. Your D 1.5 cos 45. You get your D. There it is. Then your M again equals to FD. You substitute your force that you are given 75. You multiply it with the D that you calculated. You get your M. Your M is gonna be 79.55. But when it comes to C, it's going to be negative. Why? The direction. Then our C1 is 60. It was there. Then we, for C total or CR or C results, what are we going to do? We just plus C that we got there, which is negative, and C1, the one that was there. When we put it together, we get the answer. We get the answer. Alright guys, thank you a lot. Our broadcast is this is the end today. This is the end of our broadcast. So thank you. Thank you.